Hey guys, it's Bill, and today we're going to be talking about piecewise functions. So first, what is a piecewise function? Well, a piecewise function is a function that is defined by two or more equations. So let me give you an example of a piecewise function. So f of x is equal to x minus 2 if x is less than or equal to 0, and 2x plus 1 if x is greater than 0. So I'm going to draw that. So we have our x and y axis. Okay, so let's draw x minus 2 first. If x is less than or equal to 0. So I'm going to shade the y-axis a different color so that I know that I can't go past the x equals 0. So the point 0, negative 2 is part of this, and it's a closed circle because it includes 0. And point negative 1, negative 3, so here, and it goes on. Let's draw 2x plus 1, and we can keep this because we know that x is greater than 0 and we can't cross it. So the point 0, 1, and it's an open circle because it does not include 0, and the point 1, 3 are all part of this line. So the expression x minus 2 represents the value of f when x is less than or equal to 0. And the expression 2x plus 1 represents the value of f when x is greater than 0. So let's say we wanted to find for when x is equal to 4. Let's say we want to find x is equal to 4. So in which equation would this work in? Well, it definitely can't be the first one, x minus 2, if x is less than or equal to 0, because 4 is greater than 0. So it has to be the second one, because 4 is greater than 0. So we plug it in. F of 4 is equal to 2 times 4, which is 8, plus 1. F of 4 is equal to 8 plus 1, and it's equal to 9. So that's how you solve for piecewise functions. So let's do this example piecewise function with f of negative 8, f of 5, and f of 10. So let's start with f of negative 8. So negative 8 is obviously less than negative 2. So this is the first one. The first rule is the rule that we're using. So f of negative 8 is equal to 3. Since we don't need to change anything, it's just 3. And the next one, f of 5. So the rule negative 2 is less than or equal to x, which is less than or equal to 5, includes 5. So that means that we're using x plus 2. We're not using 4x because x is greater than 5, does not include 5. Okay? So f of 5 is equal to x plus 2, so 5 plus 2, which is 7. And our last one, f of 10. So we know that 10 is definitely greater than 5, so f of 10 is equal to 4 times 10, which is 40. So f of 10 is equal to 40. So that's how we solve for piecewise functions. So let's write a piecewise function for this graph. To start, we write f of x is equal to, okay, so let's start with the line on the left. So we have the point 0, negative 1. So we know that this graph includes the x value of 0. So then we can obviously say if x is less than or equal to 0. And we see that this line has a slope of 1. Let's calculate it using the points, the formula. So we have the point 0, negative 1. And we have the point 1, 0. So 0 plus 1 over 1 minus 0. And we have the slope of negative 1. And we have negative x minus 1. So let's plug in, let's plug in the point, the x value of negative 2. So negative 2, which is 1, and yeah, it works. So let's find our equation for the second line here. So as we can see, we have an open circle. So that means it does not include x is less than or equal to 0. And if both lines include the same point, then your function or graph is wrong. So that can't be possible. So we know that if x is greater than 0, and it does not include 0, so we have the point 0, 2, and we have the point 1, 3. So let's calculate our slope. 3 minus 2, 1 minus 0, which is also equal to 1. And the y-intercept is 2, so we have x plus 2. So there you go. That's how you write a piecewise function from a piecewise graph. So there you guys go. I hope you guys enjoyed the video about piecewise functions. If you guys want to suggest any topics for future videos, feel free to leave them in the comments below. Otherwise, I'll see you guys next time.